Hi students, welcome back. I'm Joe Cooper-Sannon. We're moving into lesson 3. This is video 3A. The main topic, in lesson 2 we looked at graphs. Now we're going to look exclusively at categorical variables. How can we start to summarize categorical variables? It's really easy. All you're doing is counting. Okay, so let's not make this harder than it is in lesson 3. Summarizing categorical variables. If we're looking at categorical variables, just let's collect some data, maybe put it in a spreadsheet, load it into StatCrunch. You'll usually be looking at just lists of words. Now remember, categorical variables are typically words, but you could have numbers if you're using like a coding system to number your outcomes. So usually we're looking at lists of words, and like I said, we can summarize this data by counting. We can summarize by counting things up. Typically with large data sets into the hundreds of observations, we're going to want to let StatCrunch handle those gritty details. In the video lessons, we already have counted up data for us. It'll be presented in tables. Okay, so in class we'll take care of the StatCrunch. On the next slide, I do have an example. This is not the one that's in the notes, and hopefully the video picks up this. This was Cecil student data from a few semesters ago. We ran a survey on StatCrunch, and we asked students a few questions. You may have answered these exact same questions yourself at the beginning of the semester. What's your living situation? Some of the responses were we gave them choices: live with parents, rent. These are a bunch of live with parents. We also had own, and then we gave a something else category, all living with your uncle on the couch, or whatever it happened to be. This is a list of words. This is a categorical variable, and if I want to analyze this, I'd start counting up how many students out of the 200 students are renters, for example. Okay, bills was another categorical. Do you pay bills? Don't you pay bills? When I moved to commute here, this was the distance to school. This is a quantitative variable. We will take care of those in lesson 4. So basically we're looking at categoricals and we're counting things up. What's the primary summary statistic? Well, there's two forms of it. One's in decimal. We would call that a proportion. And the other one is a percentage. If we take a proportion, move the decimal places by 2, we're multiplying by 100. It'd be a percentage with the percentage sign. The questions we'll be answering are things like what percentage of students rent at Cecil College? What proportion of students pay all of their bills? Rather than split with a spouse or have their parents pay for their bills. So we're looking at percentages or proportions. It's really easy to calculate. I mean, by hand, no problem. You just put your sample size in the denominator here, and whatever you're counting up goes on top. The small number always has to be on top. I think this came from the Cecil data. I think we had 91 students, and I think 19 of them paid all their bills or something. I mean, who knows what it was? I can't remember, to be honest. But it's just 19 out of 91. Here's the proportion as a decimal, and here's the percentage with the percentage sign. Okay? We'll need to be able to move back and forth from these quite easily, so make sure that you can do that pretty speedy. Okay, to the example in the notes. I have data from New York City. This was in January of 2012, and what we're looking at is every interaction with police officers in New York City. There were 69,073 police interactions during that 1 month, believe it or not. I mean, it's a huge city, but 69,000 people being pulled over or stopped by the cops on the street. Every person pulled over, questioned, stopped is included in this data set, and I have lots of categorical variables. Here's gender. Either you're male or female. The police department recorded race. I believe there were 6 separate races by their record keeping. They had black and white, Asian, and then white Hispanic, black Hispanic, and American Indian. Okay, this is categorical. Whether or not you were frisked, yes or no? Once you were frisked, whether or not the police officers found anything on you, drugs, guns, who knows, and whether or not an arrest was made. Okay, so these were the variables in this data set. Back in the previous lesson, lesson 2, we looked at graphs. Every variable is categorical, so what graphs could we make, right? We're using these. We're using those bar plots or bar charts. It means the same thing, and your pie charts. So I believe there is a pie chart. I can see it in my notes on the previous slide. A lot of times we'll make a graph to see visually what's happening in the data set, but then we'll want to start calculating some proportions, which is exactly what we're going to do right now. All right, get this out of the way. Students, when we're looking at one variable at a time, we can make some tables. When it's one variable at a time, it would be called a frequency table. Frequency table, I'm going to just add a few things here. This would have the counts. Okay. Now we could also put the percentages or the proportions. These are the raw counts. And we'd throw a word in front of frequency. We would say relative frequency. So this could also be named relative frequency table. And all that is just the counts or the percentages or proportions. All that could be on the same table, in fact. Okay, so that's one variable at a time. If we're looking at two variables, it's called a contingency table because you're looking at how one variable is contingent or is related to the other variable. So contingency. These are easier because you're looking at one at a time. These are a bit more challenging because you're seeing two variables and how they interact. All right, so let's look at that New York City data set. Here's the pie chart. It's in the notes. Of those thousands and thousands of arrests, you can see the breakdown by race here. Okay, and what's the question? I guess we've got an A, B, and C here at the bottom. All right, so we've got, here's a frequency table, relative frequency table. Question A, what is the percentage of police questionings involving people of Hispanic descent? All right, so it looks like all the questions on this page are based on relative frequencies. So what happened in this table is that we took the total number of black arrests and divided it by the total number of arrests. You would just tally up this. I don't have that total on me, but it's that 69,000 number from the first slide. And these are the percentages. Okay. What percentage of police questionings involved people of Hispanic descent? There's two subcategories of Hispanic. We've got white Hispanic and black Hispanic. Because those are disjoint or separate groups, this is a really easy question. All I have to do is add the 25.8% plus the 7.3%, and I'm there. Okay. We'll add them up as decimals, so what do we got? 0.285 plus 0.073. Add them up on your calculator, you get a 0.331. Of course, we know that that is 33.1%. Just move the decimal 2 and put the percentage sign. Okay, so what percentage of police questioning is Hispanic? There it is, 33.1%. All right, another easy question looks like, part B. What percentage of questionings involved people that were not white? What percentage of questionings involved people that were not white? Two ways to tackle this. I could add black, Hispanic, Asian, American Indian. All right, and I'm going to call white Hispanic separate from just white the way that I'm reading this question. So actually, I'll put an X there too. To answer B, I can do this the long way. I can add up black, white Hispanic, Asian, American Indian. That will be the answer, because those are all the categories that are not white. The other way to do it is just say, look, these have to add up to 100%. So I can just take 100%, or I could take a 1 as a decimal. I subtract off the 8.9% or the 0.089. And if I take 1 minus, this is in proportion form or decimal. This is 100% minus 8.9%. All right, if we do that, you get a 0.911 or 91.1%. All right. Either way, we're always looking for the easier way, and I think this is the complement rule. We'll get to it, but taking 1 and subtracting to arrive at this. All right, part C then. It looks like there is a second example on the back page. Part C, according to census figures, 25% of the population in New York City is classified as black. Yet, check this out, 54.4% of the police interactions involved black folks. Would you say that race and propensity to be questioned by the police are independent variables or dependent variables? Okay. If they were independent, this is a little bit tricky because we have limited information, but let's sort of circle what we know. If I look at all of New York City, according to the census, 25% of the residents are classified as black. Okay. If it was independent, if your chances of getting arrested or questioned by the police had nothing to do with race, the percentage of black folks that are being questioned should be pretty darn close to 25%, right? But it's not. It's more than double. It's 54.4%. All right, so how can we summarize that? If race, that's one of our variables, and I don't want to write this again, but propensity to be questioned by the police, I'll just call that propensity, ... you know what I'm talking about, were independent, which means race has nothing to do with your chances of getting questioned by the police. If they were independent, this should be close to 25%, right? The percentage of blacks being questioned would be close to 25.1%. That's if they were independent. Nowhere even in the ballpark. This is more than double, more than half of the arrests in New York City were, of questionings were of black residents. So clear-cut dependent, clear-cut dependent. It's not, so I don't have much room to write here. This is probably the most dependent thing we've seen in this course at this point. Okay, so this should, if it were independent, I'll wrap this up. If this were independent, then this distribution should look just like the racial distribution in New York City. For instance, if say 40% of New York City is white, then 40% of the police questioning should be of white folks. If 25% of New York City is black, then 25% of the police questioning should be of black folks. But it's not. This probably differs substantially from what the census would tell us. All right. We'll look at a contingency table to wrap this up on the next page. Let's see, there it is. Let's explore the relationship now between gender and the likelihood that you get arrested, actually. So you've been questioned. Now what's the chance you get arrested? I know what I would say, and I know I'm guessing what most people would say. I would say if you're getting pulled over or questioned, I would say males are much more likely to be actually arrested. Okay, but we have the data here. So, I mean, it's just my thought. We have data so we can see what's going on. This is a contingency table. I have two variables. Over here is gender. You're either female or male. Over here is, were you arrested, right? Yes or no? And so we've got those counts here, and we can look at the interaction between those two variables. This is a contingency table when you see 2. All right, so let's answer the questions so this video doesn't run 45 minutes long. Part D here, what percentage of people stopped were arrested? Here's the trick. What am I taking a percentage of? I'm taking a percentage of all people. So, when I make my fraction, what's going to go on the bottom? The grand total, 69,073. That's the grand total in the bottom. We're looking at if you were arrested, grand total of 3,816 people were arrested. Okay, so 3,816 over 69,073. I can't do that in my head, but I did my homework. 0.0554. That's about 5.52%. Please, students, be able to move from one to the other like instantly. You've got to know that this is 5%. This is not 55%. Okay, this is 5%. 5.5. All right, that's D. Move on to E. Part E, what percentage of females stopped were arrested? Make some room. I guess I could have left the underline. Now the question says what percentage of just the females? So really, this is all I care about in this contingency table would be the row of the females. Percentage of females, what am I taking a percentage of? It's the 4,865 females. What percentage of these ladies were actually arrested? 367 out of the 4,865 were actually arrested once they were pulled over or stopped on the streets. 367, 4,865, that's about 7%. Equals 0.754. And of course we know instantly this is 7.54%. I'm looking at my notes. I don't know if this is statistically significant, but if you look at the general population, 5.5% getting arrested once they're stopped. If we look just at the ladies, 7.5% actually getting arrested. I don't know if that's telling us anything, if this was just an unusual month. It's a 2% difference, but it actually looks like females are slightly more likely to get arrested once they're stopped. Again, it's only 2% difference, so I wouldn't read too much into it. All right, part F. What percentage of males stopped were actually arrested? We're getting the idea. We've got to read these super carefully. I'm looking just at the males, only the second row in the table. How many males did I have? Bottom of the fraction, 64,208. Of the 64,208, how many were actually arrested? 34,49. Go to the calculator, it's 0.0537. And of course, instantly we know that's about 5.37%. I can start looking at independence, dependence. I could look at overall, what's the chance you're actually arrested? And then I can break it down by gender. What's the chance if I'm male, I got arrested? What's the chance if I'm female, I got arrested? There's not much of a difference here from males to the general pop. A little bit higher percentage females, maybe telling us there's a slight dependency. All right, G and H, and we're done with this video. Read the questions carefully, students. What percentage of people stopped were males? Of people tells me to put 69,073 in the denominator. I'm not just looking at females or males, I'm looking at percentage of people. 69,073. If we look, what percentage were males? Well, just about all of them, right? 64,208. It's no surprise this is not close to 50-50, right? This is a vast majority of people getting questioned by police are males. And that's about 92%. 0.9212, 92.12%. Trying to think, New York City, almost everybody walks or takes the subway, right? So there's not a lot of driving infractions. If I had to guess, I don't know, but I know a lot of people who live in New York City don't have cars. I suppose if there was more automobile traffic, people driving, that this may be closer to more of an even split, but who knows, right? This is overwhelmingly male are the people getting questioned by police. All right, letter H, last one. Percentage of people arrested. What percentage of people arrested were males? Uh-oh. Looks like a little typo there in the notes. I can guess exactly what the heck this question was supposed to say. So let's just change it, students. We already did males. Who's left here? All right, change that to females, please. Sometimes things slip through the cracks. You can either take 4865 over the total, or you can just do 100%. So for part H, females would be 100% minus 92.12%. What's that leave us? About 7 point something. 7.88%. So if we look at these two combined, here's the female-male breakdown, females versus males. Clearly we can see there's going to be a dependency, right? Depending on your gender, it's much more likely to be pulled over if you're males or stopped on the street compared to females. Because there's no way this is, if you looked at New York City is not 92% male, it's 8% female. Okay. All right, we'll wrap that one up here. Thanks for watching. We'll see you in class.